Okay, so yeah, thank you very much. We're very excited to be here and loved the workshop so far. So we hope we can also contribute something. And what we're doing, so it's Sofía. She's a PhD student that just started in the Cascade project, which is a Marie Curie doctoral network that we have on looking at computation and analysis of semantic change across different environments. And she's basically looking at how we can model context and the relationship between different type of contexts, the interplay. And what we've done in previous work that I'm going to show in order to see how she's then going to apply this is with model context and with different approaches separately. And we would actually like to combine and see the interactions. So the project that I'm going to illustrate is going to, let's see if this switches. Sorry. Oh, no. Yeah. Okay, so it's going to focus again on the chemical revolution, and we already had quite an introduction on the Royal Society corpus, so I'm not going to go into it. And basically, we have this shift between phlogiston theory that was there 100 years and then was replaced by oxygen theory. And we're going to take this as a pilot, basically, to look at this. And we're going to model different type of contexts that we're interested in as we go. Now, we're linguists, right? So we're mainly interested in the how language adapts to these changes in the world, basically. So we're looking at language variation and register theory. And basically, this states that the situational context that we're in determines the language use that we have. So if I'm giving a talk to you about the topic, or if I'm writing a paper, my language will differ. And also that the linguistic context has in the language system variation that makes this basically possible. So we can have expressions of particular concepts in different types of linguistic encodings. So we can have air, which was dephlogisticated air, and then the concept and the term of oxygen. And we tie this also with rational communication and information theoretic accounts as one possible explanation of why things might change. So that variation is there in order to help us to modulate the information content, in order to optimize when we speak, for achieving efficient communication, but also keeping the effort reasonable that we have. And I'm going to explain this a bit more. Okay, so we're interested in when do we actually encounter change and what basically changes, and we do this in a similar fashion as Sergey has shown. So rather than comparing predefined periods, which was traditionally done in corpus linguistics before, we detect change by looking at couplet library divergence, so comparing people from different time periods, and if the time periods are farther apart, we would assume a higher divergence, and we model this continuously on the timeline, so basically bins of previous and past years, and then slide over the timeline and do this again. Now, what we end up with is this diachronic comparison where we look at peaks and troughs. So whenever we have peaks, we have diverging periods. So this is just the lemma level here. We're using an Alexis. And so we see these peaks and then troughs again, where people actually converge again on how they use language in past and previous periods. And then we can inspect, similarly to what Sergey has shown, that there is this period where a particular type of lexical items appear that drive basically these changes. So people were basically talking about how they experimented with air, that air was dephlogisticated and things like that. And only later we actually have the terms that have been used. At the same time, we're also interested in what grammar does. So you see, we don't throw out function words, we actually keep them, and we also look at the grammatical level. So we can see then what type of patterns, so these are, for example, part of speech trigrams that we use, are actually used at the same time and also produce peaks and are actually helping basically what is happening at the lexical level in terms of expressing terminology. So having adjectival patterns such as the phlogisticated or nominal phrases such as oxide of iron, for example. We've also, back in the days, modeled the semantic space. In a sense, this is a simple word-to-vec method, but it also showed like the phlogiston space and how that was completely replaced by oxygen terminology, basically, and how phlogiston left the space, basically, and became smaller and smaller. Now, we were also interested in who is actually leading and spreading the change, right? And here we used what has been used also in social media analysis on Twitter and came from looking at earthquake detection. So cascade models. I'm not going to go into the detail, but just because of time lag, but I'm happy to do so later. So basically we have particular people in the chemical revolution that were actors, and we looked at how they used chemical words. And these models help us detect who is actually an innovator and who is actually someone that is actually someone that is influenced by the innovator. And so Priestley was the one in our corpus because it's a UK corpus that was actually leading this change. And then he influenced George Pearson heavily. And Pearson was one that was actually an early adopter, but also a spreader, basically, had also spreading it to other people. And then we have, for example, late adopters. So this is how we tried to look at how people are influences or influencer. And then we're also interested in how change is actually realized linguistically and why it changes, taking up this communicative perspective. So one of the possible reasons of why we have these type of changes. And for this, we use the notion of surprisal, which is very similar to what Jochen has shown. So predicting the next word, basically, right? So what LLMs also do. So Jane bought here, probably each of us would say or end the sentence differently. Right? If I have Jane read, most of you probably will say book, right? So book is quite predictable in the second phrase than in the first phrase, which it would transmit more information. And we can look at this also in the chemical text and also very locally. So this is the first mentioning of oxygen in the text by Priestley, basically. So it's high in surprise. It has a lot of information for the people that were reading it, let's say. And while if we see something like air over here, which is really tiny, right, it was very predictable after the phlogisticated. And let me go back. So it has been shown that surprisal is proportional to cognitive effort. So we can say something also about how people process language. And if we look at different types of encodings that we can use basically and how this changes over time, there's some kind of structural compression that we're able to do. And we can look at the surprisal of these phrases basically. So whenever these are mentioned at first, they have relatively high surprisal, but then more people are using these things and surprisal goes down until it reaches some kind of saturation point. And this is then the time when a more compact a notion basically can emerge, right? The compound version basically. And this is something that we've seen for many of these terminological patterns, but we don't see this with something like point of view or so, right? So this is only within terminology that whenever the cognitive effort is reduced in terms of lower surprisal, then a shorter encoding can actually emerge, right, and establishes in the community, and is also used more often. Now, we've used all of these separately, basically, and now what we're trying to do with Sofía is actually to try to see the interaction between these contextual factors. So I give it to you.
Thank you, Stefania. Okay, so to model the emergence of oxygen theory and the decline of phlogiston theory, we are targeting the chemical revolution period. And this method that Stefania already described finds the distinct terms to represent both theories and also the periods that we should look at. That is the first step. The second part involves how to represent the interactions that led to the emergence of oxygen as a concept. We use BERT for the term embeddings. And for the features, these are mostly, as they showed us previously, categorical features, authors, journals. Some are more complex, such as linguistic patterns and part of speech tags. But let's just focus on the categorical ones for now. We use one-hot encodings. Sorry. And we create a node feature matrix for every 20 years. Then we measure the change between the node embeddings. This to estimate the distances between the nodes. And finally, to reduce the complexity of this graph, that is, we have a lot of links, and this is too computationally expensive to model. We use different methods. This is a proposal to use a community deduction algorithm just to find what is the ideal modularity structure. Then, once we have this graphs, how do we estimate the latent relationships? Maybe some authors were talking among themselves and they were not referencing it explicitly in the text. For this, we use a combined approach of a transformer graph convolutional network. The data that is leveraged is the semantic embeddings from BERT, the contextual metadata, all of this in the node embeddings representations that are fed into the graph convolutional network. This one learns patterns in these profiles and predicts new links by capturing the structural relationships. And with the transformer, the attentional weights are used to find those nodes that are highly influencing interactions within the graph. Finally, now that we have this latent relationships, how do we identify if these are meaningful? We use this method to find isomorphic graphs. That is, over time, those structures that were maintained. Okay, and these are the limitations and perspectives. I'm not sure how much time is left. Okay. Well, the first one is, what does it mean to computationally trace conceptual change? Can models capture not just linguistic drift, but deeper epistemic shifts? How does context become part of meaning in language models? Also, is the metadata external noise or a core signal? As you may have noticed, in this project, we are tackling not as noise, but something important. What is the unit of language change? A sentence, a term, a topic. And are shifts best observed at the level of words, concepts, grammar, or discourse patterns? Can we identify recurring linguistic pathways for emergence of concepts? And, well, I'm going to skip that one. Finally, what are the limits of interpretability in complex models? That's it. Thank you.
Thank you. Discussion. I count arms. 1, 2, 3. Did I overlook? I have 3. So 1.
Thank you for this interesting discussion. And I think it's really important to do this kind of work where you take, this is based on the Royal Society corpus as well, right? Where you take a corpus like this and you really dig down into it and try to map the shifts and the concepts over time. Again, I would only caution, there must be historians of chemistry in the room who would say, like, why not be more ambitious? Because why not take a French journal? Why not take a German journal, right? Make it multilingual, because what they were doing at the time was very international, very multilingual. And, you know, you can't make assumptions about the chemical revolution without talking about Lavoisier, right? I mean, so all the stuff going on in France and Germany, even the UK, the British example from the Royal Society is not complete. We had a lot of stuff going on in Scotland at the time. So you could, if you wanted to add more English language sources, you could take what's going on in Scotland too with Joseph Black, etc. So I love what you're doing. I just say go bigger for the historian.
I have an observation here. So on the last stage of the methodology, the entity alignment part, it's a task in which you find relationships between entities that have different names. This is normally used, for example, for machine translation. This is only a pilot study presentation, but what you're saying is in our future perspectives, for instance, in the last stage, adding another data set, maybe from a French journal, as you mentioned, to address Lavoisier, and compare the oxygen subgraph with the oxygen, I'm not sure how it's pronounced, subgraph, and see if based on the neighboring nodes, the entities are identified as the same, as aligned entities. So instead of Caboche, it will be another graph convolutional network instead of a link prediction task for a entity alignment task. Yeah, but that's envisioned. Thank you very much for pointing it out.
Maybe I can say something. So I would hope you would be one of our reviewers if we would like, write a proposal for a bigger thing, because there are also letters, there are other types of text that might show, connections, in this sense. So multilingual, but also other type of text types that we could actually leverage there. Yeah.
Thank you. 2 Friedrich, 3 Malte, and I take myself on 4.
Okay, thanks for this case. Actually, the first part was mainly addressed already. So my question was, what base of data do you have? And of course, as you fairly mentioned, it's not at the time you should look at monographies too, at books, much more when at least as much went on in books as did in the academy journals. But okay, this was the first part. The other thing is, how do you, often enough in such texts, when, for example, the term oxygen was meant or showed up, or dephlogisticated air, can you decide, can you differentiate was it sometimes it came up in a positive or in a actually rejecting mode, and this would make a difference, wouldn't it? So how do you deal with those cases? And of course, this is just an example for many of these cases. It was a very heated debate, and people used the same terms, but in actually the very opposite direction.
Yeah. Yes, thank you for this question. So the Cascade has also another PhD student that is actually looking at propaganda. And there was really, Sofia have seen like there was also propaganda in the phlogiston and oxygen era. And so we're going to try to actually look at these strategies of how people have actually, looked at these things positively or negatively. Nastya is actually doing this in the Russian-Ukraine war, but we're going to try to map these 2 projects in order to look at, for example, this type of propaganda and propagandistic strategies linguistically in the text. So if oxygen or dephlogisticated air was used positively or negatively. And Priestley used a lot of phlogiston too, right? So, and probably in a different, in a negative way, maybe, yeah. Does that answer your question?
Perhaps I haven't got it really. How do you do the differentiation then? You may have the same word sample, but in the opposite direction. How do you do the differentiation?
Okay, I thought we had an image of a graph, but maybe not. Imagine a graph, node and other nodes linked together. What will be the structural differences between the 2 concepts? And also during this period that Stefania mentioned, before, during oxygen theory, there was a lot of resistance from those advocating for phlogiston theory. So I will expect to see in the network structure a lot of edges referencing the concept of oxygen, but maybe linking it to something else, like, I don't know, a critique or another adjective that is very despective. I'm not sure back in the day how they were refuting the theories of others, but it will be interesting to see the linguistic patterns used to give less worth to a theory that's appearing and contradicts the mainstream theory, and also to see this shift in the network structure. So it's no longer a comparison between vectors and using some distance metric to evaluate them, but rather the structural features, how they shift, which nodes are promoting more edges. Maybe this one that was associating all of these adjectives to oxygen to make it less appealing was an author that we can match to books in philosophy of science that was indeed criticizing oxygen because they were advocating for phlogiston, for example. So in short, looking at the network structure of the graph and comparing it over time.
I think we go to 3 and we might elaborate on it if we still have time.
Thanks a lot. There was, I mean, my first question was already answered. So this alignment in multilingual corpora, really fascinating how that could work. What about the metadata? I wanted to ask, so do you also have authors as part of the vector? And do you have, can you also show these relations that you alluded to earlier, who is like early adopter and late adopter and so on? That is one part of the question. The second part is, would that a similar method also work for current era corpora like the quantum gravity corpus, so that we can see how the community that builds around, that we detect only in retrospect by looking at language, is building up in changing language? That would be really fascinating.
Okay, thank you for the question. The metadata is the same that they presented already, Diego and Sergey. We have categorical values such as author, journals, topics, and then more complex metadata, linguistic patterns, parts of speech tags. That's for the first question. Regarding the second one, I'm already forgetting. Oh, okay. The relationships between the authors?
Yeah. Yeah, so the influencer-influencee, I think, yes, it can be applied. Was your question?
I just remembered, sorry. You were referring to the general...
Could we clarify the question again on one sentence spot?
No, I just
And,
remember, sorry.
No, let him do it again, and then you have the chance to answer concisely. Can you repeat that? There is a confusion. You don't want to repeat? Okay, then you repeat this.
Yeah, because you said to use it, how will it work for other data, right? So here, I guess a protocol will need to be established to put this in a relational database, because to translate a relational database, such as SQL, through a graph is relatively simple. And let's say that you also have some columns, categorical values. This could be leveraged in the graph as well. But here it's a matter more of data engineering rather than the method itself. So if the data set is different in its columns, obviously it wouldn't be applicable directly. It will need some processing. Yeah.
But were you asking about the influencees? Yeah. Yeah.
No, now we go. You had the chance to clarify. Let me go back. I'm on question 4 to the answer of Friedrich, because I have the feeling you didn't answer it. So the question was, you have a very interesting novelty criterion here, and it seems to work pretty well with the term of oxygen there. So it immediately pops up as a novelty, so as a new information, and you proposed a Shannon measure of information content, of entropy or something like that, to detect this novelty usage of terminology. So when this novelty occurs, it is bound in your analysis to the new occurrences of a token. as far as I understand. So my first question is, how do you exactly calculate the entropy value there? Because it usually needs a lot of data. It's a probabilistic measure, and you need to get in lots of numerical information to get this measure right, which is critical, especially in the moments when you have only one token appearing new.
Yes.
So
mean,
one
what-
question, and then
I-
I would like to come back to Friedrich's question.
Okay.
Is there a possibility to assign more than the surprise value to a token, like a negative or positive attitude in using this token to make statements, for example?
Yeah. Okay, thank you. Yes. So basically what we compare are probability distributions of the words, and the KLD allows us, because it gives a weight for the comparison that we're making. And so it also can basically show up the less frequent words that can be distinctive. And it's also a matter of, I mean, the word could have been there before, air, for example, right? But in this period is distinctively used in a way that it's different from the past in terms of its probability distribution. So the word don't have to be new words. They can already have been there, but then in terms of the probability distributions and how they're used in that time frame that we're looking at, they pop up basically. Yeah. So does that answer the first question?
Also, each term is no longer alone. It has aggregated metadata, the author, the journal, the linguistic pattern, all of this data that we can use to enrich the representation is aggregated. And then we use the distance metric, Kullback-Leibler divergence, to measure the difference between this term graph with the ones of years after. This way, we have not only a distance between the word embeddings, which is a traditional approach, but rather the node embeddings, the subgraphs of this term against those that appeared after, expecting to see an addition of authors, maybe journals, and so on.
And for the second part of the question, yeah, I think there, so yes, we can run something that, so linguistically might show that the terms are used in a positive or negative context. But I also think that we would have to talk to historians of science, of the chemistry of science, in order to validate what we're going to look at, or also, you know, getting insight in what we should look at. But if we would have that, then it could be modeled at some type of contextual variable that is changing in terms of the linguistic frame. Is that what you're after, or? Because
yes, it's the question. From your answer is you want to see something like the golden standard by which you can compare your linguistic patterns of the occurrence of that word, and you want to use that standard as a benchmark in order to train your models to make an appropriate evaluation. The question is, could you do that without benchmark?
So
you don't have a historical pre-configuration of novelty or even negative usage, but simply from deducing it from the linguistic composition, from the content.
Yeah, we haven't addressed this, but this could be addressed definitely if it is used in a negative or positive context. But it might also be very subtle. That's what I'm saying. So maybe with linguistics, we might not get to it. And so we would need to know, for example, that some are opposers and these, you know, the words that are used in this text are actually in the other community rather than in the oxygen community. So I think it's not going to be only maybe with linguistics that we're going to tackle that. Is that, yeah.
Thank you.